Hi guys, my name is Galip Sharifov. I am a physics teacher. Today we will talk about the motion on an inclined plane. According to the pedagogical experiments that we have carried out in at different type of the schools, we have disclosed that there is a big challenging among the students regarding to this topic. Therefore, I decided to give the detail in more detailed explanation about this topic. And let's start. And if we notice the surrounding and everyday's living, we can we can face with the inclined plane, like the skateboard ramp, slide, water slide, and funnel, roof ramp, and etc. And in order to explain the motion and which force are acting on this object, let's suppose that we have a object on the inclined plane. First of all, let's define that what's the inclined plane. It's this surface that is tilted at an angle relative to the horizontal, and therefore this surface is called the inclined plane. And let's start explanation about the let's start to give the more explanation about which force under of which force this object is going down or going upward direction. Okay, in order to explain it, in order to discuss it, we have draw the y-axis and x-axis. You see that the direction of the x-axis is downward direction because we suppose that this object is going downward direction. So the three main force, this object under the three main force are acting, and the first one of them is a normal force. Normal force is always the normal force is at a right angle to this surface or perpendicular to this surface, and friction force is always on the x-axis, and the main feature of the friction force is that to oppose the object going downward direction. And if we pay the attention to this gravitational force, you see that gravitational force, direction of gravitational force is downward direction, and we can avoid to this gravitational force. And you see that this force is not on x-axis, is not on y-axis and x-axis. Therefore, we need to break down this force into two components: parallel component and perpendicular component. We from the picture, as can be seen from the picture, we can states that this parallel force causing this object going downward direction is always makes the object going downward direction, and it's always this force is always opposite to this friction force, and the force, perpendicular force of the gravitational force, that's the component, perpendicular component, is always opposite to the normal force. And from here you see that there is a angle of alpha between the gravitational force and its component, perpendicular component, between the gravitational force and its perpendicular component. And if we take aside the two triangle, you see that one of them is obtained from the inclined plane, and others one is obtained from the combination of the forces. And as you see, according to the similarity of the triangle, we can say that this alpha is this angle is equal. Therefore, in order to find the force parallel and force perpendicular, we can use this angle, and we, according to the triangle, we have found that force parallel equal mg, so the gravitational force equal mg sine alpha, because in order to find the sine alpha, we need the force parallel divided by g or mg. From here, force parallel we have found like this, and force perpendicular component of the gravitational force equal mg cos alpha. And normal force, as I said before, that normal force is opposite to the force perpendicular force. So normal force equal mg cos alpha. You see that the perpendicular component and force normal is equal to each other. And as to friction force, we know that the friction force equal mu multiplied with normal force. And we have found the normal force, and from here we can put this equation instead of the if in, and as a result we can find the friction force equal mu mg cos alpha, and here is his you see that mg sine alpha and mg cos alpha. And as can if we to take the if we look at these three pictures, we can see that the gravitational force is equal in all these pictures, but depending on the angle of the slope, the parallel force are increasing. Parallel force increasing, and perpendicular force is decreasing. You see that decreasing. It means that with increasing the angle of the slopes, the force parallel is increasing, and this leads to the moving of the object downward direction. And we are going to explore the three cases for this object that's placed on this slope. And first case is if the force parallel is less than friction force, the object is at a rest. From here we can find that mg sine alpha is less than a mu mg cos alpha. And second case is force parallel equals the friction force. In this case, the object is in uniform motion, so the velocity of the object is equal. And from here we can, if we apply the Newton's second law to this case, we can find what does it states. According to the Newton's second law, it states that the resultant force or net force equal thrust force minus friction force. Thrust force in this case is a force parallel, and according to it we can say that ma acceleration equal force parallel minus friction force. So the equation force we know that mu multiplied if n. From here we can see that acceleration is zero because the velocity is a constant. And from here, this equation, we have found that mu equal tan alpha. Tan alpha. It means that according to the angle, we can find the friction of coefficient of the friction for this situation. And third case is if the force parallel is higher than friction force. So friction force is less than force parallel. The object is in uniform accelerated and motion, and we if we apply the second law to these situations, as we have done it before previous slide, and we can see this equation becomes like this: ma equal mg sine alpha minus mu mg cos alpha, because if in we have found the mg cos alpha, force parallel we have found the mg sine alpha. And from here we can find the acceleration for these situations. You see that acceleration is g sine alpha minus mu g cos alpha. And in order to find the final velocity of this object, and if this object is freely going down, so the initial velocity for this object equals 0, and we can find it like this from these equations: final velocity equals square root of the 2 multiplied a multiplied length of this slope, so inclined plane, the length of the inclined plane. And if we put instead of a, if we put the equation for this acceleration, we can find the equation for the final velocity like this. And if the friction force 0, so friction force is a 0, this surface is frictionless, so the resultant force for these situations equal only the force parallel. And force parallel, if the force parallel equal ma, and we can see from here a equal g sine alpha, so mu g cos alpha becomes 0 because the friction force equals 0. And for the final velocity, for the object that is placed on the frictionless surface equal square root of the 2 multiplied the length of the inclined plane multiplied g sine alpha. G, it's the gravitational intensity. And if we apply the additional force, for example, additional force, because we came across different type of the challenging, and this challenging is so that it is more difficult for the students to compare all these forces, and therefore we give each of these forces the different color. You see that this green color is the additional force. This green color is so green color force, let's call it like this: green color force is downward direction, so is in the direction of the force parallel. And from here, if we apply the Newton's second law, ma equal force, you see that force plus force parallel, because both of them are the downward direction and to the direction of the x-axis, so it's a plus. These forces are plus, and minus friction force, because the direction of the friction force is opposite to the x-axis, so it is a minus. And from here, if we put the equation for each force in this equation, we can find the acceleration for this situation like this. And from here, final velocity equal square root of the 2 multiplied the length of the slope and multiplied the acceleration. And instead of the a, we have put this equation. So if the velocity is a constant for these situations, and ma becomes 0 because the resultant force is 0 according to the Newton's first law, because if the force the resultant force is 0, the object may be at a rest or maybe in a uniform motion. And from here we can find the equation like this. You see that like this. And if the green color force, so green color force, direction of green color force is opposite to the x-axis. So uh, this green color force as a friction force oppose the object going downward direction. So here we can write Newton's second law like this. Ma equal force parallel minus, you see that minus because in this case the green color force becomes a minus as a friction force. So force parallel minus the friction force, so mu Fn, and minus this green color force. And from here, we if we put each we if we put the equation for each force in these situations, we can find the acceleration like this. And in order to find the velocity force, we have obtained this equation. And for the uniform motion, so the velocity is zero. Velocity becomes a constant. So the resultant force is a zero. And if we change the position of the green color force or and the friction force, we can obtain this equation like this. And here is the uniform accelerated upward motion. Till this time we have talked on the downward direction, but in this case you see that x-axis is upward direction because in order to choose the direction of the x-axis, the first things that we need to pay more attention is the direction of the motion, because the x-axis is always on the direction of the motion of object. And from here, ma equal force minus force parallel, and in this case force parallel is a minus because this force parallel becomes as a friction force, becomes the friction as a friction force and oppose the object going upward direction. And ma, you see that ma if minus mg sine alpha and minus mu mg cos alpha. From here we can find the a equal like this, a equal to this equation. And in order to find the final velocity, we need to take into consideration the initial force. And in order you can see this equation is as a more challenging, but it's not very difficult. It should not be very difficult for you because we have put on the equation of the acceleration in this situation. And if this object is going in uniform motion, and so the velocity becomes a constant, and so the zero acceleration equals zero, so resultant force equal zero. In this case you see that the green color force equal the sum of these forces. Which forces? Force parallel and friction force. You see, friction force. And if we pay more attention to these pictures, we can see this man going downward direction. In order to apply the Newton's second law, we need to firstly to find the component of the gravitational force, and you see that free body diagram for this, and free body diagram for this, and this is free body diagram is widely used in different foreign country. And let's focus on the example. You see that example, in order to solve this problem, let's read the question. For example, let's suppose that we have a block with a mass of 5 kilogram on an inclined plane, and the angle of the inclined plane is a 30 degree, and for the first case, this surface is a frictionless, so there isn't any friction force. And here is, in order to find the force parallel, we have known from the previous slides that the force parallel equal mg sine 30 degree, and mass is a 5 kilogram, gravitational intensity is a 9.8 multiplied the sine 30 degree. From here we have found the 24.5 Newton. And in this case, in order to find the acceleration for this case, we know that the acceleration equal resultant force divided by mass of this object. Resultant force in this case is only the force parallel. So we now, according to the our finding, is a 24.5 divided by 5 kilogram. We have found the acceleration for this case. So this block is going downward direction with the acceleration of 4.9 meter per second square. And the next case is the with the friction force. So in the second case, the slope, this surface, is not frictionless. So the mu equal 0.2. And from here, we can find the friction force mu mg cos alpha, mu 0.2, mass 5 kilogram multiplied the gravitational intensity and cos 30 degree. It gives us 8.5 Newton. So the net force or resultant force equal, as I said before, that's thrust minus the friction force. Here in this case, thrust force is a force parallel. So 24.5 minus friction force that I have found 8.5, and it gives us 16 Newton. So this object under the 16 Newton going downward direction. With which acceleration, in order to find it, we have said that acceleration equal resultant force divided by mass. Resultant force for the second case is 16 Newton. So 16 Newton divided by 5, and it gives us 3.2 meter per second square. So today we have learned the motion on the inclined planes, motion of the object or along the inclined plane. We have found that in order to solve the problems regarding to this topic, we need firstly to draw the y-axis and x-axis. And after it, we need to find the component of the gravitational, find a component of the gravity, and after it, we can apply the Newton's second law. So thank you for your attention, and I hope that this lesson will be more useful for you. And don't forget to subscribe to my channel and hit the like button. Also, don't forget to leave the feedback in the comment section. Okay, bye. See you next lesson.